So now we are into some examples where we're going to determine the exact value of a trig ratio. When you're dealing with something like this, always be looking for your special triangles. So again, these are on your data sheet, but look for special triangles. That's not how you spell special. Special triangles. Now, in order to figure out exact ratios, we're really going to utilize reference angles here. So reference angles are going to be a very important thing to figure this out. So let's zoom in here, and we want to determine the exact value of cos 135. So let's first of all identify where cos is on our Cartesian plane. So again, we should know by now that knowing our quadrantals angles are a very important thing. So we got 0, 90, 180, 270. So now we want to roughly draw where you would find 135. So 135 degrees is going to be between 40 and 180, or sorry, 90 and 180. That was a little bit of a mistake there. So here, this is our standard angle we're talking about. Now, in order to discuss our angle and figure out what cos 135 is without a calculator, that's what an exact value is. So first of all, if we just decide to plug in cos 135, you're going to get a decimal number, but it's obviously not exact. That's not an exact value. So this is where we need to use our understanding of possibly our special triangles. So let's figure out what this reference angle is. Because if this reference angle is either 45, 30, or 60, then we know we can create our triangle, a special triangle here. So in order to figure out this reference angle, we need to discuss the fact that we know that from our positive x-axis to the negative x-axis, that's 180 degrees. Remember, in order to figure out this reference angle, we have to do 180 minus 135, because if we take away 135 from 180, you can see we're just left with our reference angle calculation. So this will be 180 minus 135. And let's plug that into our calculator and see what we get. So 180 minus 135, and we get 45 degrees. So remember, the special part about creating terminal arms at our vertex or at our origin point is we can always drop down and think about our triangles here. Now recognize we weren't given a specific coordinate point. We were just told that the terminal arm is forming a 135 degree angle with a reference angle of, again, 45 degrees. So recall that with a triangle, we have 45, we have 90, so that automatically will make this 45 degrees here. And hopefully you can see now we're dealing with our special 45, 45, 90 special triangle that we discussed last chapter in chapter 2.1. So that's our 45, 45, 90 triangle. So at this point, you would go to your data or formula sheet and see that you have a 45, 45, 90. Now you just want to accurately place the values that line up accordingly. So opposite to our 90 degree angle would be our root 2. So opposite to our 90 degree angle would be our root 2. So our radius here is going to equal root 2. Or sorry, not our radius, but our hypotenuse. And then, as you can tell, the reason the 45-45 triangle is special is because it's an isosceles triangle. So opposite to this 45 is the length 1, opposite to this 45 is the length 1. So realistically, we know that both of these side lengths are a length of 1. Now, the main important thing here is what area or what quadrant we live in. We are existing in quadrant 2 because we're talking about 135 degrees. So my y coordinate is definitely a positive y coordinate. But remember, we are living on the negative x-axis. So we have to recall to put a negative on our x coordinate. So this point here we could say is -1 and 1. So that's super important to note, is what is the, let's maybe make that this color here so it'll pop out a little bit more. You have to remember that there is a negative. Our x coordinate is negative. Okay, so that's huge, especially because we are dealing with cos 135. So remember, now we have the ability to say, well, if I want to figure out my standard angle, I'm going to use my reference angle. In this case, my reference angle here. So cos angle, as we can see from our data sheet, is x over r. What is my r and what is my x? So my x value is -1. My r value is √2. And we could place down our y value if we needed. Our y value is +1. And now we have enough information to answer our solution. So cos 135 is going to be the x coordinate to 135 and the r coordinate. As we said, that's -1, and r is √2. And there is what cos 135 equals. So let's check that again. Hopefully it's in our calculator still. No, it's not. So again, let's plug in cos 135 and just see what that gives us. So it gives us a non-exact value, it gives us a decimal number, but let's check what -1 over √2 equals. So -1 dividing square root of 2. And you can see that it equals the same value. But this is our exact value. So this here is the exact value of cos 135. And there's our solution. So hopefully that made sense, me walking through how to solve this question. Again, whenever you're given a standard angle, figure out what that reference angle is. And if that reference angle is anything that has to do with your special triangles, then you know very well that you could start focusing on these side lengths. You kind of automatically know what those side lengths could technically be. Okay, so let's maybe move on to the next example here and give this next one a shot. So this one is very similar, but a little different because we're dealing with sine 240. So determine the exact value of sine 240. So as soon as you're given an angle, figure out where that angle lives. So just like before, we draw out our Cartesian plane. We got 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now 240 degrees exists between 180 and 270. So I'm going to draw a line here that exists between 180 and 270. Now, as soon as I start drawing that, I'm already noting what my y and my x values. Notice when I have an x value here, it's going to be negative. When I have a y value here, it's also going to be negative. So I'm kind of keeping that in the back of my brain. The angle I've just drawn here is my standard angle of 240 degrees. And now I kind of want to ask myself, am I able to use any of my special triangles? So if I drop down a leg there and I form a 90-degree angle, there's a 90-degree angle. If I can figure out if this is 30, 60, or 45, then I know I can use my special triangle ratios. So let's see if that works. So I'm going to determine what this reference angle is. So hopefully by this point, you have an idea of how to solve for that reference angle. The reference angle here, well, if we take 180 away from 240, you're going to get rid of this whole portion and be left with this. And that's going to be your standard or your reference angle. So I'm going to do 240 minus 180. So 240 minus 180, let's pull out our calculator here. 240 minus 180, and we can see that gives us 60 degrees. Okay, so at this point, we know that this is 60 degrees. We also know that there's a 90-degree angle here. And from here, hopefully you can see if I pull up my formula sheet, I have 60, I have 90, so that automatically makes this side length 30 degrees. So now we're dealing with a special triangle. And at this point, I can start listing my side lengths. I just have to be wary of which side length corresponds to what. So I usually look at what the opposite angle is and then plug it in from there. So in this case, the hypotenuse is 2. Here's your hypotenuse, which is technically r, but you could also think 2 is opposite of the 90-degree angle. 2 would be opposite of the 90-degree angle. So this here will be 2. And this also equals r in this case. Now, what would be the side length of your y value? Well, this would be the leg that is opposite to the the 60-degree angle. So let's go to our special triangle. The leg opposite of our 60 degrees is root 35, or root 3. So this will be square root 3 here. And then finally, what will this be? Well, this is going to be the opposite of 30. Opposite of 30 is 1, so this will be 1. Now, ask yourself, what am I missing with these numbers? You have to consider, is my x negative, is my y negative? My x will be negative because I exist in quadrant 3. My y will be negative because I exist in quadrant 3. So here, x and y are negative. And now at this point, you have your triangle and you can start listing off the coordinate points that you know. So here, we know tons about this. So for the angle 240 degrees, list what you know. I'm going to do this in a different color. So for the angle 240 degrees, what is the y coordinate in this case? The y coordinate is negative root 3, found right here. My x coordinate is negative 1, and my r coordinate is 2. And now you have the ratios to successfully solve for sine 240. So recall in your data sheet that this tells us that sine angle equals y over r. So in terms of sine 240, my y value is negative root 3, and my r value is positive 2. And there is my solution for sine 240. And let's check here. Let's plug this in, sine 240 degrees. So again, not an exact value, a decimal. And let's check what negative square root 3 dividing 2 equals. And it gives us the exact same solution. So this is the exact solution there, which is great. So let's shoo this away. And from there, let's do a bit of an extension question. You can solve even more of the question here. So what if it asked us what cos 240 was? Well, we know on our data sheet, cos is x over r. And now it's a matter of saying, well, I know what my x coordinate is. My x coordinate's negative 1, and my r coordinate is 2. So it looks like the exact value for cos 240 would be negative 1 over 2. And let's plug that in. So when I plug in cos 240, what should I expect to happen? I should expect negative 0.5 to pop up, and I absolutely do. And then you could finally even additionally figure out what tan is. If I wanted to know what tan 240 is, we'll look on your data sheet. Tan angle is y over x. So tan 240 would be our y, which is negative root 3, our y value, and our x value of negative 1. And here, remember, our cast rule. What does cast rule tell us? Cast rule tells us everything that should be positive. So in the third quadrant, tan should be positive. So far, this is true. Sine is negative, cos is negative. And now here we can see that negative and a negative cancel out. So tan does happen to be a positive root 3. And that would be a solution there. Let's plug that in. Tan 240. And let's plug in root 3. And you can see that we get an exact solution and an estimate. So your calculator won't know how to give an exact solution. That's what our brains are for. So there was the year turn. Hopefully you attempted it on your own to see if you were able to figure it out. We're starting to near the end of 2.2. 2.2 is a very packed portion of the learning. So if you have any questions at this point, please let me know. Other than that, thanks for watching.